Hi everyone. Today the hall seems to be unusually thin. Usually we have a packed hall, but I don't know whether it's the weather or it's the pollution, one of them. Also, it so happens that Mr. Vajpayee is unable to be present here today. So he has sent a message which we will play as the introductory one. Because he had some family emergency and the whole family had to travel. May I have the...
Welcome to you this evening on behalf of the Raza Foundation and India Habitat Center to the 10th session of Art Matters, a series which we have been running for a while, about 2 years, to explore publicly many aspects of architecture that go comparatively unnoticed. This is a series which is part of a larger group in which we have Art Matters, Gandhi Matters, Literature Matters. Raza Foundation is a non-profit charitable trust created and funded by the iconic Indian modern Syed Haider Raza, who was very keen to create a large but reflective, creative, open forum of the multi-arts. And this is part of that series. We are very happy that you're here. My apologies for not being there because I'm in Bhopal and I cannot make it to this evening. Welcome once again. And now Professor K.T. Ravindran, who has been curating this series along with Kabir Vajpayee, would introduce both the series and the speaker this evening.
So, I'll first give a small brief introduction of Dr. Arun. Dr. Arun Menon is a professor of structural engineering at IIT Madras, holds his first degree in architecture, and then moves on to do structural engineering, and then he has a PhD in earthquake engineering from the University of Pavia in Italy. Pavia is in northern Italy and also has, I think, some of the finest classical, Roman classical buildings in the world, like based on Vitruvius principles and so on. So it's quite appropriate that Arun is with us today to connect the Shastras with the building practices. So he looked at earthquake behavior of historical masonry structures and earthquake-resistant modern structural masonry. He currently coordinates the activities of the National Center for Safety of Heritage Structures, NCSHS in short form, a Ministry of Education, Government of India approved, supported research work at IIT Madras. He has been an expert member at the International Coordinating Committee for the UNESCO World Heritage Site in Bagan in Myanmar, and currently is a member and expert advisory group of the expert advisory group to International Conservation Committee in Thailand for a UNESCO World Heritage Site. In Laos, not in Thailand, I'm sorry. He has been involved in conservation projects in India. Many of them he did with INTAC here. So we have known each other through INTAC as well for quite a long time. And he has worked on the Rashtrapati Bhavan here, structural conservation of Rashtrapati Bhavan. IIM Ahmedabad, which I'm sure is a matter of great interest to a lot of the architects here, because IIM has been in great controversy in recent times when it was slated for demolition. So he did the structural conservation for it. He worked on the Madurai Meenakshi temple, on the Konark Sun temple, Bhutan Tango Monastery in Myanmar, World Heritage Site. In the Philippines, he worked on a basilica, and in Somalia, another project. Arun Menon is also active in national and international technical code committees, that's formulating codes, and he is in the Bureau of Indian Standards, International Union of Laboratories, and experts in laboratories and experts in construction materials, systems and structures in Paris, and as an international council with the ICOMOS. He's been an advisory member to the body of ICOMOS. Now, what he's going to talk about today is about the link between the Shastras and conservation practice. Yeah? Because what we have inherited as conservation practice in India is largely based on the British system, where the Shastras don't figure at all. Whereas many of the old buildings that we have in India, particularly the temples, not only temples, many churches and mosques as well, were based on the Shastras at one time. And the link between the prescriptions in the Shastras and the construction practices has never been part of the learnings within our education. So he is the one who has transgressed into that domain, and he has looked at how, for instance, measurements and scaling in the Shastras actually determine the entire structure, the materials, and the way they are assembled. In other words, the structural system is dependent on measurement and methods which are prescribed in the Shastras. So that in case you understand dimensions of one component of the building, you can scale it to match the entire building. Yeah? So it's a kind of you can understand the whole building in reverse, and that becomes the basis for a more informed basis for structural conservation. This is roughly the area that he has been working in, and he's also been involved in many other structures. He'll give us some examples today. And with that brief introduction, I invite Dr. Arun Menon to please take the mic.
A very good evening. At the outset, let me thank the Raza Foundation, Professor K.T. Ravindran, Mr. Vajpayee, for this invite. I'm very happy to be here to talk of something that's my bread and butter, and I've tried to do justice to the title, the intent of the talk. I have tried to put together a few projects. Not all of them go into the ancient knowledge systems, but at least a couple of them do. And some other projects which sort of bring out the role of the structure, the role of engineering in these projects. So I hope to keep you engaged in the next few minutes. I've selected 5 projects, and I hope these are interesting projects which shows us the complexity of the subject of conservation, built heritage conservation. Let me begin by talking to you about this. Many of you may have heard of this line. It's a famous line, ars sine scientia nihil est. So when the Milan Cathedral was being built in the 1300s and 1400s, in fact, the construction went on for about 600 years as we know it. A number of architects and engineers were called because they did have issues from time to time, given the scale at which this structure was being conceived. Jean Mignot was one such person, one architect who was asked to come and look at the structure when they started having problems. So there was a committee that was examining the problems with this huge cathedral that was being built. And Jean Menon goes into all the details. He tries to find out where the masons have possibly gone wrong. And he begins his discourse. In fact, after that, he takes over the work of the construction of the Milan Cathedral. He begins his discourse by saying, ars sine scientia nihil est. And that sort of become the cornerstone for structural conservation. What he meant was art without science does not exist. And it also shows the dichotomy that exists in the world of heritage conservation. There's always this tension between the sciences and the arts. And they need to go hand in hand, but it's important to look at buildings, and in this case, monuments, and the subject of conservation of historical monuments from both these perspectives, from the arts and from the sciences. So, in the 20th century, many of you are aware that organizations such as the ICOMOS, International Council on Monuments and Sites, was instituted. This was after the Second World War, and several advisory bodies to the ICOMOS as well came up. One of them was ISCARSA, and ISCARSA is an active body today. ISCARSA actually stands for International Scientific Committee on the Analysis and Restoration of Structures of Architectural Heritage. It's a long expansion of that acronym, but basically looks at the structural aspects of historical constructions. Now, very much in line with what Jean Menon actually talks about, ISCARSA tries to give a basis, tries to give different criteria to study and intervene in heritage structures. And this body and the guidelines that come out of ISCARSA explicitly state that you need a combination of both scientific and cultural insight, and in addition, knowledge of all experts involved possible. And this is indispensable for the study and care or preservation of architectural heritage. And when you look at a very multidisciplinary stage where professionals have to interact, ISCARSA identifies that structural engineering can actually provide the scientific support to obtain the expected result. And the result is really the safeguard of the building as a whole, but with the lowest possible consequences on heritage values. So you need to intervene to preserve it. And when you intervene, you have to be conscious about what the building stands for and ensure that those interventions do not dilute or erase those values. And structural engineering there has a very important role because it determines whether the structure survives or not. So I see those words of Jean Menon to what ISCARSA tries to do today in terms of engaging with the professionals involved in heritage conservation being quite coherent. What I've tried to do today is put together 5 examples. As I said, all 5 don't deal with the ancient traditional knowledge system of Vastu Shastra or temple building, but they're all examples from India. I do have an example that really talks about where this Vastu Shastra and going back to Vastu Shastra can actually inform the subject of built heritage conservation. So let me begin by talking about the Puri Jagannath temple. This is one of the most famous living temples, which is also an archaeological monument. The Puri temple is probably one of the busiest temples in terms of the number of pilgrims visiting the temple in a day. The focus of our work was really one beam in this 800 plus year old temple in the Natya Mandap. You have multiple structures within the Puri Jagannath temple. We were looking at one beam in the Natya Mandap which had cracked. Well, it's a interesting symmetrical structure, and right in the center you actually have, you have four massive pillars, and there are beams that are supported by these pillars. And of course the roof comes and sits on top of it. Now, what really happened, what really brought us to this particular project was what happened a few years ago in the Jagmohana, which is the larger mandap that is behind the Natya Mandap. The Jagmohana, with almost a similar configuration, in its central zone, with 8 massive beams, had all the 8 beams cracked. Now, when did these beams crack was really not known. Where these new cracks, and these cracks surfaced, were visible in 2015. And the question was, did these cracks really happen in 2015? But probably not, because when these massive beams were actually plastered with lime and painted over, and there was a decision to take off all the plaster in the structures in Puri Jagannath temple. And when they started removing the plaster, they saw all these 8 beams had cracks. So what was interesting is these cracks were wide. They had completely split the stone, and the lime was actually inside the crack, which is an indication that the lime plastering was done after the crack had actually formed, and it was not something that was a recent phenomenon. So possibly the crack has been there right from the day it was completed or sometime later. But the entire discussion within this multi-stakeholder environment led to a situation where even before any scientific investigation could be done, all the 8 pillars were completely supported with very heavy steel columns, eventually reducing the space that you have to view the deity, which was really not a desirable outcome. Discussions went on for a few years, but it was a very, very difficult, very heated environment where decisions were taken without consideration of how is the structure behaving. So a few years later, when a crack surfaced in the Natya Mandap, few of us were very clear that we're not going to be putting any sort of a support system there without studying these cracks, without understanding, are these cracks really causing a structural a danger to the life of that system there, the structure there. So in this particular case, since it was one beam out of the 8 beams that were cracked, I think we had our way, and we were able to install sensors, and it's very much like the human body that you can do tests and you can have sensors there and you can study this for a period of time. Of course, you want to study them for a sufficiently long time, but a crack is a crack is a crack, and everybody wants to have some action taken when they see a crack. This was a court-monitored activity, and hence some decision had to be taken quickly, but we really had the luxury of, you need at least 2 seasonal cycles to really understand if these cracks are structural in nature and if the movement in the building is dangerous. Why 2 seasonal cycles? Because you really want to see whether the crack opens and closes with the variation in the temperature as you go from the summer months to the winter months. And if it is only that, the crack is actually just opening and closing because of temperature differences and not because of structural loading. So this needed to be established. And as I said, we had about 5 years to be able, we actually were able to buy time, examine the behavior of this crack for about 5 years. And what you see here is the cracked beam and the sets of instrumentation that was put there. We put crack meters in place. We put a tilt meter in place to basically study how the entire system is behaving. And what you see here is a system which was accessible remotely. today with all the technology that's there, we could access the data sitting in our offices at IIT Madras. And for a period of 5 years, every 4 hours, we had measurements of deflection and measurements of the tilt in these beams. And it became quite clear that at the end of the cycle, one summer and one winter, it would come back to its zero position and then continue the cycle. So you see it oscillating about a certain zero position, and this was good news, which meant we had time to intervene, and since the crack could not be left unattended, the final intervention was carried out after a few years, but in a very careful manner, not to block the view that is there of the deity or the other mandapas from the Natya Mandapa itself. So eventually those beams were strengthened by adding additional steel beams in a way that was hidden away between the existing supports. So this was an interesting project where the understanding of the structural behavior was given the time and space required to then be able to intervene in a manner that does not change the essential character of the space. And this is where structural engineering really comes in. And this project was really I would say one-off, because very often it go the other way, and then you want to put in very heavy interventions just because you're scared looking at the crack. The second project that I want to talk about is another interesting project, but there was a fire. Many of you must have visited this beautiful temple. It's the Madurai Meenakshi temple in Madurai, Tamil Nadu. A part of this temple in 2018, 2nd February 2018, it's 4th February today. 2nd February 2018, there was a fire in one of the mandapas, and this is a mandapa which is a 500-year-old mandapa called Veera Vasantarayar Mandapa, built in 1611. It was full of shops, and it had a lot of wiring. It had a lot of plastics. It had a lot of wood. And at the end of the day, at the end of the day's prayers, when the temple is shutting down, shops are closing, typically there's a ritual that's carried out. There's a camphor lit on a pumpkin and to ward away the evil eye. And then the pumpkin is broken. The camphor just falls on the floor, and unfortunately, a piece of lit camphor goes into one of the shops and then starts a fire. And this is around 10 p.m. in the night. And CCTV cameras capture this entire process, entire proceedings. And by about 10:15, 10:20, the whole space is filled with smoke, and the fire begins. And unfortunately, the fire engine stationed in the temple, this is a temple that is visited by hundreds of thousands of people in a day. The fire engine in the temple didn't have water, and so they couldn't really douse the fire immediately. And by the time the fire engines could be mobilized, the whole place the entire mandapam was burning, and there was so much of inflammable material. The fire could be doused only after 5.5 hours. And in 5.5 hours, so this is the Veera Vasantarayar Mandapam, has about 110 pillars, massive stone pillars. It's a very tall construction. The fire spread to about 50% of the structure, and hypostyle halls are typically open everywhere, and you have a slab on top. So almost like a furnace, it was heating the beams and the slabs, and you can imagine if that went on for about 5 hours. So at the end of it was about 4 a.m. or so that the fire tenders could actually douse the fires, but by then beams had cracked, slabs had broken, and the structure had suffered significant distress. What you can actually see are the broken beams, the slabs that collapsed, and what you can see here is granite that's melted. And that's something we were seeing, at least I was seeing for the first time, you can see that those beautifully carved stone beams have just become like plastic members. So this was the state, and therefore, immediately the decision of the temple authorities was to start pulling down the entire structure and reconstruct it, because this is a living temple. But that's where it was important to take a step back and really see if it was essential to pull down the entire structure, given that it's a 500-year-old construction. What was interesting in this particular, when it happened in 2018, the government announced that they would, in 6 months, build a new structure. But the wisdom of the committee that was actually looking at this, was a multidisciplinary committee of about 12 persons. The wisdom of the committee prevailed, and we were given the opportunity to really study the effect of the fire on the stone. And what we were able to discover was that the fire had actually spread only in about 50% to 55% of the entire structure. And the rest of the structure was actually heated, but was not in direct contact with the fire. And therefore, we launched a very detailed experimental campaign, a field experimental campaign, where we took samples from all the pillars which were affected by fire, beams which were affected by fire, slabs which were still intact, and systematically understood what had really happened to granite exposed to different stages of fire. And what you see here is an interesting picture. This is from a scanning electron microscope, meaning you're looking at magnifications of 500 to 1,000 times or even more. And what was seen was, in most of the structure which was in direct contact with the fire, ferric oxide was formed. You could see evidence of ferric oxide in the granite. And the fact that granite is a very strong stone is because of the presence of ferrous oxide. It's one of the strongest types of stone that you can get for construction. But then you didn't see ferrous oxide in these images. You could see ferric oxide, which meant that ferrous oxide was converted to ferric oxide due to the oxidation and the heat process. Ferric oxide is formed at about 623 degrees centigrade, which meant all those portions which showed evidence of ferric oxide had actually reached about 623 degrees centigrade. And then granite melts at about 1,300 degrees centigrade. So this was important forensic information to understand which were those parts of the structure which were actually affected to this extent, and those which were not affected to an extent of this nature. This and a series of other tests, we had in fact taken samples of stone from 6 different degrees of damage and studied what had happened to these, to the stone. We were finally able to convince the authorities there that about 50% of the construction could be retained as it is. And a 500-year-old construction need not be pulled down and reconstructed, making it a brand new mandapa, where you actually lose its historicity. The decision was finally that only 50% would be pulled down. The rest, what you see there, is retained. And currently, of course, it's about 6 years after the tragedy, 7 years after the tragedy. But the stones that are going to replace the ones that have been taken down, these are massive pillars. These are at least 20, 30 feet in height. These are actually going to be, they are being sculpted, and in a short while, the reconstruction would begin in that part of the dismantled part of the structure. Of course, if some of you have been to Madurai Meenakshi Temple, this is right next to the 1,000-pillared or the Ayiram Kal Mandapam, which is a sculptural marvel. And the biggest fear was that if there is a sudden collapse of the fire-damaged mandapam, or if something goes wrong while dismantling, something could fall onto the 1,000-pillared hall and cause an international headline. And this was a big thing that they wanted to avoid. And what was really done was a cut was made right at the top of the structure, isolating the 1,000-pillared mandapam from the fire-damaged mandapam, so that while dismantling, the vibrations are not passed on. And you can see all sorts of methods were used to cushion off anything that could fall onto the 1,000-pillared mandapam. So this is an interesting project where scientific investigations were able to inform preservation of at least 50% of the structure, and the scientific investigations continue to inform the type of stone that needs to be selected. Out of 8 quarries, we've now selected 1 quarry which has stone that matches what was used 500 years ago through petrographic and mechanical studies and so on. So this was an interesting project that saw how science can actually help in the process of conservation. The other project that I would like to talk about is the Rashtrapati Bhavan. And of course, there are many things in the Rashtrapati Bhavan that are extremely interesting. Professor A.G.K. Menon was leading that project from INTAC. This was a project where the part that I really want to talk about is the sunshades. And these are beautiful sunshades, massive sunshades. As you stand in front of Rashtrapati Bhavan, they look like small sunshades, but they're actually 2 meters cantilevers. And let me go to some details of this particular architectural feature. They're about 1.2 kilometers long if you look at the sunshades all around the building. So it's a huge amount of construction material that you have to deal with. Unfortunately, they are not in so they have this very beautiful floral pattern that you can see from the bottom. And you've got this red sandstone and the pink sandstone and this beautiful combination that this entire sunshade is created in. But if you go a little closer, they are in really bad shape. And for a moment you would think this is all in stone and what's happening. So this is not in stone. This is in reinforced concrete. It's in reinforced concrete, so you can see corroded reinforcement, and you can see that there is spalling of the cover concrete. And you don't want to have cover concrete spall off from 50 feet high as you're entering a building, when you have sunshades 1.2 kilometers all around the building, and VIPs and everybody moving in and out of the building. So this was the condition. This is where we were asked to look at the problem of the sunshades and give some solution. There was a lot of patch repairs, like we do patch repairs when there's corrosion damage typically happening. But the patch repairs were definitely not working, because the patch plus new material would just fall very soon. So this needed to be studied. We did some archival research. We found the drawings, the original drawings. Rashtrapati Bhavan maintains all these original drawings. And what's interesting is, after the completion of the building, completion drawings signed by the Public Works Department are available in Rashtrapati Bhavan, which is fantastic for any engineer or architect working. To find as-built drawings is a treasure. So as-built drawings were available. And what's interesting is the original plans from 1915 and 1930s, when this building was being constructed, was that Jaipur sandstone, the pink and the red sandstones were meant to be used for the sunshades. And there is information of the procurement of these sunshades, procurement of the stone for construction of these sunshades. And there are details of how the stone is going to be anchored into the walls, into the stone masonry walls. So then you would expect it to be stone masonry. But then these as-built drawings from 1931 actually show that these were completed in reinforced concrete, as the spalling due to corrosion shows. So what's really happening here, this as-built drawing in 1931 shows the reinforcement detail. The red color lines that you see there is the reinforcement detail sitting within concrete. And what concrete? So that was the second question. So this is a set of drawings that we prepared after taking measurements and then looking at the as-built drawings. We really needed to figure out why is there so much of corrosion. If you really look at corrosion and the types of steel that we were using 80, 100 years ago, they are not so badly affected by corrosion. It's the modern steel that gets more affected by corrosion because to make them more and more malleable, we reduce the content of carbon and they start becoming less resistant to corrosion. So we really wanted to understand what was happening, and then a series of tests on the material had to be carried out. So we did corrosion measurements. We did delamination assessment, because in certain locations you could see the sunshade losing its cover concrete, but in other locations you really didn't know what was happening because it looked intact, but it could just come down. And then we were also worried that would these sunshades just drop off? These are 2-meter long sunshades. So we had to do a load test in situ itself. And then this is a picture taken by a drone. We had our team work on the sunshades, walk beneath and walk above the sunshades. We also had the fire department come and give us their fire truck so that these sunshades could be accessed. Tests were conducted. What was very interesting was we found typically cement concrete, if cement is used in the concrete, cement should provide some amount of resistance to the movement of corrosion entraining elements. But this concrete had nothing like that. And it started becoming evident that it was really lime that was used for concrete and not cement. So multiple tests that we conducted confirmed from visual to all the other tests that we conducted actually confirmed that we were looking at lime concrete and not cement concrete. And the problem with lime concrete is lime concrete does not create what is called a passivating layer that prevents moisture and air from reaching steel. Lime is highly porous and allows moisture and air to reach the steel. And that was really the reason why in about 85 years, the entirety of the sunshades had corroded. So this was the situation, that it was an incompatible combination of two materials, lime and steel reinforcement, that led to the problem of extensive corrosion, and this had to be dealt with. As I said, we also tried to undertake studies to see how much of delamination is happening, and the statistics were really scary. So this was done by tapping and looking at the nature of sound that you get and measuring that. So this showed, this is an example of a scan, and wherever it's red, it's completely detached, and the other locations, the concrete is still, the cover concrete is still more or less intact. And the statistics were very worrying. We did 4 segments, and in these 4 segments, about 86, 58, 81, and 79% of the cover concrete had actually detached and was waiting to shoot. So it was not safe in any context. And then we wanted to do this test. So we now understood that these are sunshades built very much like they are built today. A sunshade is cast, precast, and then put in place. So we thought, yes, you've got these precast sunshades which have actually gone up there. There are multiple pieces because you can see these nice vertical lines, which means 2-meter long sunshades have actually been cast and then put up there. Those lines were actually indicating that you had these small segments of sunshades which were cast and put in place. So we decided to do a load test. We put this loading beam on top, and what you can see in the next slide is how we pulled this beam to try and see at what load is this sunshade expected to fail, because every Independence Day and Republic Day you have a lot of labor that goes on these sunshades to put up the lighting when Rashtrapati Bhavan is lit up. So there is a safety angle which needed to be addressed. So we did this test, and engineers are very interested in doing calculations, and so we did the test, and then we also tried to predict it theoretically. and you start getting really happy when predictions and the experimental observations are matching. So we had some theory by which we could actually calculate how much are these slabs expected to deflect. We did those calculations without the cover concrete and with the cover concrete, that is completely corroded and partially corroded. And our experimental measurements sat very well with the theoretical calculations, so all the engineers were very excited. Then what did we have to come up with in terms of the repairs? We found that, so what was very interesting was these sunshades were really not precast. These were actually cast in situ. And to give the impression that this was actually made in stone, they were first painted in pink and red, but they also went and put a line at the top every meter to make it look like pieces of stone. So they were really not precast, they were cast in situ, and they were all cast together. So that reduced the possibility of a single slab just collapsing when it's heavily corroded. So that was something that we discovered. Something very interesting, as we were doing the study, standing on top of it and taking measurements, there was an elderly gentleman who works at Rashtrapati Bhavan. He asked us, what are we doing? And we explained to him that we are trying to find out if the single piece would come down. When we were almost finishing the test, he said, this is all cast together, what are you doing? So, but it's good to discover the truth for yourself. Repairs, I think we went through many cycles. We decided we could do protection of the steel using what's called cathodic protection, and we implemented it for about 10 meters as a pilot study. Cathodic protection means you retain the steel, you create an electric current, and you have a sacrificial anode which gets corroded and your steel is saved. So we put that in place. We did it for about 10 meters. It worked very well. The pilot project was expensive, but it worked really well. Everybody was excited after that, and they started dismantling the concrete of the rest of the sunshades to put in place this technique. But then, in the excitement, they ended up with a collapse of a part of the sunshades, so this had to be shelved. And after that, finally, cathodic protection was done, but the concreting was done with fresh concrete for the entire segment, entire 1.2 kilometers if you want. This was put in place. All this work happened during the pandemic. And finally, molds had to be used to create the patterns that we see, which look like patterns in stone. And we also put the line on top, which makes it look like pieces of stone. This was completed, and today you can actually see fresh reinforced concrete stone look-alike sunshades in Rashtrapati Bhavan. So this was an interesting project where the scientific investigations gave multiple insights on how the construction happened and how the damage actually happened over time. This is the project. This is where this is a project of a 12th century Chola temple in a village by the name Tukkachi in Kumbakonam district in Tamil Nadu. And it's called Sri Abat Sahayeshwarar temple. And the reason for talking about this temple is really, this was a pilot project that we did in 2020 for the Hindu Religious and Charitable Endowments Department of the Government of Tamil Nadu. And this is a project where we really took some effort to understand how these temples are built, geometry, form and geometry, and structural dimensioning, because a lot of reconstruction was required and a lot of dismantling and reconstruction was required. And from that perspective, these activities are going to be done by the traditional builder, the Sthapati or the Sompura. However, the project reports are being prepared by engineers and architects who are trained in the modern way of learning. So there needed to be some sort of an understanding of each other's methods. And this project being a pilot project, we really wanted to leverage that sort of a learning. So this structure has been in distress for about 70 years and not been in worship. It's a 12th century structure, and the pilot project looked at a systematic study of systematic multidisciplinary study leading to final condition assessment and involving multiple experts, and then coming up with the project report and execution of the restoration. So it's a Shiva shrine built by Rajendra Chola and expanded later by both Kulothunga Chola and Vikrama Chola. And it's really the last phase of the Chola Empire that saw this construction. This is a picture after the restoration. The structure, the temple is called Tukkachi, and it actually comes from Durga Archi, meaning Durga's rule. So it's a Shiva temple where there is a Durga shrine, and the village is known by the name of Durga. Durga Archi meaning the place where Durga rules. And this is a temple where there was a spring which had properties, healing properties, and a number of people would come to this place primarily for health reasons. So this is the temple. This was the condition of the temple for several decades. You can see there are parts that have collapsed. There are multiple efforts to restore this. You can see that there's dismantling and reconstruction attempted, but never completed. Lots of problems. And so when we started this, this shows you. Let me see if it shows you very quickly the condition of the entire structure. Multiple portions had come down, and it was almost inaccessible in certain locations, even for the assessment. And so we had to devise methods of actually capturing the condition of the structure. We did this remote, using a drone, we had this remote access that we had worked on, and which helped a lot in the assessment, because there was definitely a safety issue in the structure. Let me move on. So the interesting part of this was when we started working on this, we really wanted to understand how would a Sthapati approach this, and what was the science with which the structure was built. Selection of materials is one, but what about the proportioning? And then we came across in our interactions with the Sthapatis of this entire science of Ayadi Ganitam. And that's something that we really don't learn about at all. And this is one of the most important design elements from Vastu Shastra, and very much utilized for temple construction. So this basically helps in planning and construction of the temple. And what does it boil down to? Ganitam is the mathematics, and Ayadi is a number. I'll tell you in a moment what this is all about. And in a certain set of formulae, very structured formulae, to even understand that they had very systematic mathematical processes to arrive at this. They would arrive at what is called an Ayadi. It's one single number. It is one auspicious number that is associated to a given temple or a given built space, and it's derived from astrological parameters. Directional influences of the earth also matter. So this one number is selected, and how does one select the number is really all mystery for us. And then this is used in the construction of the temple. And how does that happen? This number is considered auspicious. It's believed to ensure the temple's continued spirituality and durability, longevity. The longevity of the temple really depends on this Ayadi number, is how a Sthapati approaches the whole problem. But what this number is It is the basic unit of dimensioning of a temple, of the plan layout, of the elevation, of the decorative features, and everything that you can think of. So this one number determines, this one number is like the horoscope of this entire temple. It serves as a measurement for length, width, area, or the perimeter of all the structures. The sizes of rooms and all the elements are calculated using ratio and proportioning methods. So you take this number and then multiply this by as much as you want, proportion it with other aspects, and go ahead. So what is this all about? This is actually the step just before the design, architectural design in the language of the Sthapatis is Padavinyasam. So you draw the layout of the structure. So the number is selected after the site is selected. So once you choose the site after doing Bhumi Pariksha, which is also a very scientific process, it looks at the quality of the soil and does tests on the soil to understand how it performs. And after you do that, you select the number and then do Padavinyasam. And so what is this Ayadi number? A certain odd number is assumed. What odd number? We'll come to that. That odd number is multiplied with another number and divided by another number. So there's some assumed odd number, and that's the critical aspect. That assumed odd number is then multiplied, and then this entire thing is divided by another number. So a little example here. The Garbhagriha, the dimension of the Garbhagriha, the Sanctum Sanctorum, is arrived at by taking this Ayadi number, the assumed number, multiplying it by something, and dividing it by 8. It's always divided by 8. When it's divided by 8, you will get a remainder, and the remainder gives you an idea of the expected quality of that construction. Okay, so there is a metaphysical layer that comes in here, but we need to take the process as it is and understand how. So whether that Ayadi number is actually an acceptable number depends on what the remainder is, and as you can see, the remainder has certain qualities. There is an animal representing each of the remainders, but then the outcome is the important aspect. Some numbers will give you a superior quality of life, some will give you poverty, some will give you incompatibility issues, some can create situations of accidents. So there is a certain linkage between the number that's selected and the outcome of the number that is used to dimension the site, the temple. So where does this number come from? This number is actually related to the human body. Manushya Pramana, which is the dimensions which are there in the human body. Angulam, and I'll come to that. And where does this dimension of this angulam which is used come from? It comes from the grain. And grain is something that is very regional. Each region would have the grain that it produces, and you take the dimension of a single grain, and if you place, so a superior grain is one which is x in width and 2 times in height, x and 2x. If you place 8 grains together, you get a superior dimension. If you place grains together and it's not x by 2x, then your dimension 8 will have a dimension, if you place 8 of them together, you will have a dimension greater than 8 times 2 into x. So that will actually tell you whether it's a medium dimension or a superior dimension or an inferior dimension. Once that happens, this dimension of 8 grains together, the superior dimension, is referred to as 1 angulam. It's the finger, right? That's basically 1/3 inch or approximately 3.5 centimeters. So this angulam is then used for the measurement. You're looking at a period when the feet and inches or the SI system was not there, and measurements went by the local grain that was available, which meant region to region, 1 angulam could be different because it would depend on the grain size of that region. So you might end up with some surprises when you're making these calculations because it might not match with the 3.5 centimeters here, that may be because of the grain available in that region then. So this is interesting. So then the ayadi is expressed in so many angulams. This ayadi number then becomes the perimeter of the sanctum sanctorum. And then rest of the structure is a proportion of that, is a ratio of that perimeter. So what we did is to be able to appreciate this traditional knowledge system with which the temple was constructed and the structural systems are dimensioned in the Tukachi temple, we took the measurement of the perimeter of the Garbhagriha and then worked backwards to see what might have been the ayadi number used for the construction of this temple. And for every temple, there would have been a certain ayadi. So here we identified numbers like 29, 31, 729 or 731, which might have been the basic ayadi which was used for dimensioning the perimeter of the temple. There are multiple equations that can be used to arrive at this. The most complex has a set of 25 calculations, but mostly a set of 16 calculations. Shodasha ayadi is what the Mayamatam prescribes, and also treatises like the Kashyapa Shilpa Shastram also propose. So using that process, we found that the ayadi of this 12th century temple is possibly 29 Tanje Muram. Now, what is 29 Tanje Muram? Muram is, if you know, in Tamil, Muram is the way when you go and purchase a string of flowers, it's measured. So it's basically that much. Okay? Depends on the person who is actually measuring it and giving it to you. But one Muram is this forearm. Now, 29 Tanje Muram is 29 angulams. So 29 angulams, using the Tanjai rice from Tanjore, would have been the basic measurement for the temple built in the Tanjore district. So this number was the number that matched perfectly with the dimension of the Garbhagriha. And then when we looked at that number and looked at the 16 calculations that you do, we found that out of the 16, there were mostly good characteristics for the ayadi number. So that was the process that was generally done. You choose a number, try to see if the outcome is good. If it is good, continue with the construction. If not, change the number and then pick up a number which is good. So we did this, and this was a very interesting process. It gave us an understanding as to why temple is of a certain dimension, and helped us appreciate the fact that it was a very intricate system of converting these measurements into an entire structure, including cross-section of the stone walls, depths of beams, sizes of columns, and so on. So this is mind-blowing, and I think it's very important that this sort of study needs to inform conservation to be sure that we are not deviating, we are not first we are appreciating, and then we are not deviating in the process of conservation and recording it, which is the intangible knowledge in the whole system. This project was completed in 2023. The temple, which was in disuse for so many decades, was completed. Consecration was held on the 3rd September 2025, and you should visit this beautiful temple, which is known to be of sculptural quality, which is amazing. I'll close with this last project, which is again a very interesting project, which is completion of an incomplete construction in a temple. And it's very rare that you will have incomplete work in a temple, because it's considered to be the body of God. And why would you leave parts incomplete? But for multiple reasons, this is by proportions meant to be a 7-tiered, 7-storied gopuram or entrance gateway, but was never finished for multiple reasons, possibly diversion of funds or wars or whatever, but was never completed. You don't have signs of collapse, so it was not a structure that had collapsed. It was a structure that was never completed. So This is something that we've been working on from 2015. It's taken us several years to reach a stage where the approval for construction has actually come through, and construction work started in 2022. This is Pundarikaksha Perumal Temple in Tiruvallarai. If you happen to visit Srirangam, there's a town called Samayapuram which is close to Srirangam, and it's a couple of kilometers from Samayapuram. It's called Tiruvallarai, and the word Tiruvallarai means white stone. It's precious white stone, and it's basically a white-colored granite, which is an outcropping from this site, and the temple is built on this outcropping, and a lot of parts of the temple are constructed out of this stone. So we had multiple experts again come into this. We had historian, archaeologist, again the Agama experts, the traditional Sthapati. From our side, we did all sorts of, we had to demonstrate to the Hindu Religious and Charitable Endowments Department that if we construct the 5 stories that are missing, the structure is safe, because it's almost 500 years after, almost 700 years after its completion. So we did a lot of non-destructive testing. We looked at strength of the stone, strength of the brick, and tried to see if we add 5 stories to it, how is it expected to respond. So all the simulation that was done, and this was probably the first temple, Gopuram, where we had drilled through about 4.5 meters to understand the layering of the stone, and that gave us an understanding of how the Sthapati actually does the calculation in terms of the wall cross sections for such massive constructions. Interestingly, the structure, Gopuram, is built on a rock outcropping, so it's in a very stable situation. It's not on soil, and the brickwork is, upper portion is in brickwork and the lower portion is in the white color granite, and this is excellent brickwork with not even a plant growing in its joints, and you can imagine the quality of the joints for that, to prevent growth of vegetation. So this is currently approved. This is conjecture. It did go through a lot of discussion between archaeologists, engineers, conservation architects on whether we should even allow completion of this, but the decision was finally in favor of completing it. And again, based on the original dimensions, the Sthapatis were able to demonstrate that it was meant to be a 7-storied construction. This is currently underway, and these are some pictures created by the Sthapati to explain how the flooring will be done, and we did the structural proof checking of the floor loads and so on. And finally, this was the day when some of the damaged stone elements had to be replaced, so a crane had to be used for moving stone from inside. When you construct, you can see what you're constructing. But here, you needed a crane to stand outside, go inside and pick up something without the visual contact. And I think it was marvelous to see how the Sthapati was on a walkie-talkie with the person operating the crane and was able to ensure complete safety and complete perfection in the execution of the work. This is the situation today. We are at the 5th story, and in 2028, the consecration is expected. So if you happen to visit Tiruvallarai, you'll be happy to see this project. I stop here. I think structural engineering is found the neck, because it's all about survival. The blind man there, I think the structural engineer must have found the neck. But conservation is a complex field. You have multiple stakeholders. Everybody is correct. And that's more difficult to arrive at a final conclusion. Thank you for your time.
So, thank you, Arun, for that fabulous talk, where so many things that one had vague notions about have been brought into focus and clarified. Yeah, I won't spend more time commenting on what has been said, but we have some time for questions. And I'll request you to, can somebody pass the mic? I'll request you to please identify yourself and then ask the question.
My name is Varun Khurana. I'm not an architect by training, but it's an amazing presentation. There were two questions. One, Shastra is the publication also from IIT Madras. The fest also, I think, is called Shastra, and the title also is Shastra. That's one thing. And second, have you done some projects in North India, in terms of temples? Rashtrapati Bhavan is also there, but in terms of temples in northern India.
Thank you. The credit for the title goes to Professor Katie. I can't take credit for that. North India, yes. Kedarnath temple is something that we have worked with after the floods in 2013. The Ram Mandir is something that we are working with. We've been working. IIT Madras was in charge of the foundation for L&T, for Larsen and Toubro. Yes, so we've been working quite closely with the Sompura, Ashish Sompura, who built the Ram Mandir.
Hello. Yeah. It was an amazing presentation. I really enjoyed it.
You
My
have to
name is
introduce
Kirtana.
yourself.
Yeah, my name is Kirtana. I'm actually a history student, not an architect by any nature. But I was still wondering, was there ever a scenario that you faced while you were employed in a project working with temples or any such sacred sites that could involve a paranoia among the temple authorities or the people, wherein they feel that this scientific method conservation is more or less altering the authenticity or the traditional, nature associated with any such temples? Because the last project that you mentioned, I think it was the Perumal temple, because it's an addition to it, apart from the historicity of what the structure was like. So was there any sort of, opposition or something like that you felt or heard of from the people?
I think, India is a very vibrant democracy. And I think we discuss things a lot, okay? And with that temple, with the Pundarikaksha Perumal temple, where the Gopuram is being completed, it went through so much of discussion. There's one point in time where the engineers in the Hindu religious and the endowments department wanted reinforced concrete slabs, and we were okay. It could be reinforced concrete slabs, or it could be the Madras terrace slabs, the traditional construction that is adopted in South India. But then there was a lot of discussion on the fact that from the Agama principles, which inform temple design and temple construction, and the principles adopted by the Sthapatis, steel is considered one of the lowest materials in the classification for use in a temple. Stone is the highest, brick, and then mud, and then the metal comes really low. And metal can come for the idol, but in the form of panchaloha. So metal per se is not seen, a single metal is not seen very well in the context of these constructions. So reinforcement anywhere in the foundation or in the reinforced concrete slab was something that was not acceptable. But there was a discussion on this. And then there was a different solution that was possible. We went with the Madras terrace construction, and that's what's being executed there. But the catch there was, since we were the structural engineers involved, we had to do a proof checking and sign off saying that this is safe. And that was interesting because then we could study the system better and prescribe some deviations which ensure structural safety in this construction as well. So yes, situations were there, but then a lot of dialogue and solutions were definitely there at the end of the process.
The name's Alok Jain. Would you sign off on Sthapatis architecture from the perspective of modern architecture? Could you vouch for what they do?
This is, the signs that they use for construction of temples is static and something that they use even today based on the prescriptions several hundred years ago. So if you ask a Sthapati, the Sthapati would say the best that can be created is already prescribed in the text. And you just have to use those principles and try to achieve the best that you can. So the 13-storied Srirangam Rajagopuram, or one of the most complex mandapas that have been built, is already a standing example of what's prescribed as per these texts. So that's where I say it is a bit static. It's marvelous, the process is fantastic, the outcomes are mind-blowing, but it's static. It does not allow experimentation, or it does not allow experimentation in the way we see with new materials and new forms and so on. That's where, if you look at religious structures in other religions, you can see a lot of innovation that's coming in, which we don't see in the Hindu religious architecture. So from that perspective, it's a very complex system of construction, design and construction, very superior, because it's very superior from the perspective that the structure and the sculpture is conceived together. And that can make any modern day engineer or architect go mad, because the Sthapati is able to conceive the size of the block that he can harvest, cut, have a sculpture on one side, and then locking into the wall cross section on the other side, and conceive the entire structure like that, which today we don't do. We simply build some cross section and then do a cladding and make it look as fashionable as we want it to be. So it's highly superior. It's much superior than what our construction systems are today. Durable, extremely durable, but static. And therefore, there can be new dimensions to it even today.
Good evening, sir. First of all, I'd like to give my appreciation towards the effort put behind the presentation. I had a doubt regarding something you said in the presentation. My name is Parth. I'm a third-year student at NIFT Delhi. So my question is regarding Ayadi Ganitam, which was the old unit of measurement that was used by the in the fourth case study. So I wanted to ask about the angulam. So the grains of rice must have evolved over the past 9 centuries since when it was constructed. So where did you reverse engineer the Ayadi for the perimeter of the temple? And at the same time, the elders of the temple would know which kind of temple it is. For example, if it's for the dog or for the cow. So won't that create a bit of a issue while calculating the measurements?
Yeah, actually this is a pretty convoluted sort of a set of calculations. Ayadi Ganitam is just the calculations. Ayadi is the number. And that table with 8 numbers, that's just the remainder. That's not the number itself. The remainder has a quality. So you want to choose a good remainder. You don't want to choose a bad remainder. Yes, the grain dimensions are very regional. They must have changed over time. But we don't go back there. What we are doing in terms of the reverse engineering is, we are measuring the perimeter of the sanctum, outer perimeter of the sanctum, in SI units. We are measuring in feet and inches, or in centimeters and meters, and then assuming that 3.5 centimeters is 1 angulam, or 1/3 of an inch is an angulam, and then trying to convert it to the overall dimension in angulam, and then seeing if that dimension can be converted into murams, 29 angulams, 29 like the one that we arrived at for the Tanjai muram. So we are doing a reverse engineering, but not going to the grain dimension at all, because that's again a complete unknown. That's a dimension that we can actually work on with some botanists to appreciate this better, but we didn't go there. We try to understand if you arrive at the total perimeter in angula, which might have been the number of the IRD. What's the IRD multiplied with to give you the perimeter? And the IRD, the thing that I didn't say is the IRD number is then linked to the star of the presiding deity or the star of the Karta or the king or the star associated with a certain village. So there's a very intrinsic link between the number that is chosen for a temple to be constructed with the person commissioning it or the god that's presiding over that temple or the village itself. So this was really the process.
Can I also add a little bit to this? Actually, it's not always through direct measurement of grains and angula like this, etc., that the dimension is done. Dimensioning is also done by a series of mathematical formulae. And those mathematical it is believed that the whole universe works under one mathematical formula, and every grain or every component, every element, every room, every dimension is a microcosm of that universal formula. So based on that, there is a whole series of mathematical derivatives which are called kaikanak, which literally means equivalent is like a thumb rule. And that is an oral tradition which is made by heart by the Sthapatis. And that's very strictly preserved within that specific working caste group. It's not allowed to go out of that group. Yeah? So it's always learned from father to son, not to uncle to nephew, and so on and so forth, but stays within that framework of the caste group. And it's like like modern formulae, like a Coca-Cola will not give out its formulae to Pepsi. It's like that. They preserve it within their own group. And that is then subjected to Padavinyasa. That is converting the entire thing into a mathematically formulated set of numbers. And that number is made by heart by the Sthapati. The normal worker who is working on the stone itself by his or her hands, his hands, only men work on the stone, generally. Women only help in sharpening the instruments and so on, because there is a kind of a ban on the utilization of the female labor in work. And then that dimension is only known to the Sthapati himself, who is like a sutradhar. Yeah? Below the Sthapati is a person known as the Takshaka, who is the actual artisan who does work. And in between there's someone called Sutradhar, who is a kind of a project manager. I'm putting it very crudely. But there is a whole series of people who hold different sets of knowledge, but all converging into one universal formula. And that is the basis of actually arriving at so this whole Padavinyasa is worked based on that, not only on the measurement of the rice, like Arun just pointed out. The origin is from the measurement of the rice, but then it is also corroborated or supported by a set of mathematical formula which don't change. And so the dimension remains the same. So this reverse engineering that one is attempting can be arrived at through number of different routes. So if you know one component, you know the dimensions of the rest of the components. And based on that also the material is chosen. How they choose the stone is that they take a wooden hammer and they hit the stone. The Sthapati alone can do it. Hits the stone, and the ring that comes out of the stone tells him whether it's a male stone or a female stone. So stone has a certain gender. Yeah? And male stones are prescribed only for certain functions, and female stones are for some other functions. For instance, the example of the cracked beams that he showed probably is some kind of an oversight or a short-sightedness on the Sthapati who actually chose the stone. Because when a beam is chosen, a particular type of beam is chosen. And when you ring it with a wooden hammer, the resonating sound that comes out of the stone also shows where it has defects and whether it has different composition inside, that is the materiality of the stone changes inside, or it has cracks, or it is not integral. Yeah. That also they can make out by this thing. It's a very refined and very evolved technique of understanding which stone is suitable for what. That once that choice is done, then the dimensionality is applied to it, and every material's behavior yields a certain system of building, and that system yields the architecture. So there is really no appended ornament to architecture, but it's integral to the way things come together through the mathematical formula. Please ask the question to Arun. Yeah, sorry, I spoke too much.
My name is Rajat, an architect. My simple question has been that the measurements are object-oriented. For example, if I want to start the construction, Padavinyas calculation, fine. Now, do I put a center line or place the first layer according to which dimension? I mean, if I say in modern way, space and object, so the dimensions, how they determine the object, the space, or that is an outcome of the objects which are determined. How far? And then how do I start laying down? Do I lay out through a center line principle like we do? If I look at the section, that's reasonably complex matter. One side is straight, one side is even in Islamic structures. So when I lay it down, how I start the layout on ground on basis of which center line? Is that dimension is controlled by the object culture or not? Because in a very remote way of looking at these things like a modern architect, it seems that space is not an issue. What we call space, as you an architect as well, that is not an issue. It will be there, huge or small. Is that dimension or the object dimension and that multiplication derives some speciality?
At least the way, so this is very interesting because, the Sthapati is so evolved. The engineers and the architects just fail in front of the Sthapati's way of addressing construction. After the site is selected, so the reason why we took up this pilot project as a case study was because we were working very closely with the Sthapati. And in fact, I should tell you, if you know this website called NPTEL, National Platform for Technology Enhanced Learning, NPTEL, all the IITs came together to make series of lectures, almost 1,000 courses on NPTEL. NPTEL is a repository of courses, and you're not charged for it. You can go to YouTube and see all the courses. So NPTEL had a special lecture series where we invited this Sthapati that we worked with. And on the NPTEL platform, you will find about 50 recorded lectures where this Sthapati is going through two texts, basically, Mayamatam for temple construction, Dravidian temple construction, and Kashyapa Shilpa Shastram, that's another text that the South Indian temples are built according to. So he went chapter by chapter and he goes through the entire process of how a temple site is selected and construction begins. And as you said, drawing, where do you draw a large piece of paper is not there, and then how do you transfer it to the ground? It gets transferred to the ground first. The center line, so they do a process where there's an installation made on the site. On a certain auspicious day, they look at the shadow that this piece makes on the site and then mark the 4 cardinal and the rest of the directions, and then start from there in terms of the first measurement of the sanctum and so on. And many of these have been added over time. They were never conceived as one piece. They grew over time. In fact, the multiple mandapas that you see are just layers added later. But this is how the process began. It was on the ground that it was marked, and it was 1:1 scale. And directions were marked in this manner. Yeah.
These Stapati's role and formulae, they couldn't be the same in the north and the south, or aren't there substantial regional variations? And I get the impression that the Stapati has considerable flexibility. It's not a very rigid science form.
Absolutely. It's very flexible. In fact, you have text, you have codified texts, but there's a lot of freedom in interpreting, not in interpreting, in the permutations and combinations that one can do, and that's where the ingenuity of a Stapati can actually emerge. Again, it's not only the dimensions, but it's also the material that is selected. So one would go between stone and brick and lime and so on. And the fact is that the basis for the construction of the South Indian temples from the North Indian temples, there is a difference. Largely forms, without getting into details, are comparable, but there are significant differences. So the texts that govern the development of geometry are very different. Yes, so if you're working with the Ram Mandir, for example, Sompuras from Gujarat were the ones who were doing it, and so you had to look at their basic texts to carry out the calculations and so on. In the south, it would be, as I mentioned, in Tamil Nadu, it's Kashyapa Shilpa Shastram. In Kerala, it's different. Tacha Shastram, it's a different process because timber is used a lot, so there are significant differences regionally in the science.
Arun, with your permission, may I also just add one point to this? Actually, there are lots of variables within the context of a site. The dimension of the site, like he said, the person who is actually ordering the actual construction work, that person's caste, position, all kinds of things are involved. And there is also a whole chapter called Bhumi Jadagam, which is literally the horoscope of the site. So that depends on the dimensions of the site, not simply in terms of the measurements of the sites, but the proportions thereon. That's how the European notion of proportion, like the golden rule is 1:1.618 is the golden rule. Yeah? But here it is not the actual size. It is the relational entity that is formed by a number of measurements. So there are lots of things which actually change from one side to the other. And depending on when you look at Bhumi Jatagam, the criteria that's used is also the latitude and the longitude. And there is also variations in location between North India and South India. Even within Tamil Nadu itself, from one location to the other, there will be variation. And there will be variations in the dimensions also. One mudam, like he said, like this dimension, will be one in one location and will be different in another location. And depending on whether it's a Raja who is building it, or whether it's a trader, or it's a landlord, or whoever is, or an ordinary person who's building it, the dimensions also vary. The Raja's mudam will be bigger than that of the ordinary man's mudam. So there are multiple variations which are taken into consideration by the Sthapati while arriving at the proportions. And it's not just dimension, but it's the proportions between dimensions which are auspicious or inauspicious. So there's a basic variation between the way we understand proportion in the Western science and in the Vastu system. Just give him the...
Is there a notion of...
This is Rajiv Sethi.
I'm so sorry, Rajiv Sethi. Is the notion of asymmetry alien to Shastric tradition?
Thinking of it now, it appears so. There is a preconceived symmetry to all these forms that are made. But you also see asymmetric layouts. And I think the asymmetric layouts are, the asymmetric layout is because of organic growth over time, temples growing as new kings keep increasing their sizes. But there's a very strong element of symmetry, and
Is it a statement negating an asymmetric thinking? Or is it a system for that too?
I don't have an answer for that question. I don't think I've looked at it from that perspective. Okay.
Thank you. Sharon, you had a question?
I don't know. My name is Arun Bhatia. I don't know whether this question is relevant or not. But how do you light up these structures? These are old structures. And how do you light up these structures today?
Well, today Philips comes in and lights it up for you. And in fact, there are guidelines on what they can do and what they cannot do.
Yeah, because all kind of wires going everywhere.
Yeah.
I mean, how does it gel with,
No, so this is a very important question because, see, Tamil Nadu, for example, has about 9,000 historical temples. It has about 42,000 temples and about 9,000 historical temples. And to make people aware that when you work with such constructions, don't go and fix wiring and drill the way you would do everywhere else. It takes a lot of energy to kind of put this out, that you need to do it in a very tasteful manner and not damage the body of the structure. And there are some marvelous examples. If you actually go look at the Srirangam temple, Philips has actually done a marvelous job there, but with the involvement of professionals to ensure that the lighting is adequate, not and subdued, highlighting rather than in your face. It's possible, and I think it's important that we do that as well.
I also read somewhere there is a Wi-Fi technology by which you can transfer electricity. That is something very new. So I don't know. That can be utilized.
Can help. Yes. Yes.
My name is M.B. Chandra. I work for media. I have 3 questions. One is regarding this fire which took place in this temple. Because of a small camphor, it spread. Have you done any advised people or any precautionary work so that it doesn't occur in any other of the temples? Any such things have been done? And the second is regarding the crack which you showed. You said the timing, we don't know what is the timing, whether it is part and parcel of the construction or it is, it was created afterwards. So you clear that thing. And you talked about some, what is that? Bhumi, kya bola aapne? Bhumi horoscope, something you talked about. Measurement while making the construction.
Yes.
So explain what it is, he wants to know. And the third is that, that which Kumbakonam temple you showed. In that, I have forgotten the question. Chalo, you answer these 3 questions.
Yes, no, you're going to test my memory now. The first one, the fire, yes, this was one of the most devastating fires in the recent years. A few decades ago, there was a fire which led to a lot of loss of life as well inside the Brihadishwara temple. So the Tamil Nadu government, especially the endowments department, has taken this up very seriously and mandated certain norms inside these temples in terms of practices, and also mandated the presence of the firefighting lines inside large temples. So yes, there has been a response by the department, and in the master plans that are being developed for conservation of major temples.
The lighting can also burn.
Yes, yes. So definitely this is being looked at very carefully to ensure there are no untoward incidents. That's the first one. The second one was the crack. The crack, see the beauty of this construction is in the Orissa architecture, to place the beam in position, they used to place wrought iron beams like tracks and then push this big beam into position. Now, if the stone beam has cracked, it's not going to collapse suddenly because the wrought iron beams are still there beneath them. So in all the places where the stone beams had cracked, wrought iron beams are still there. So that's the reason why there was certain level of safety existing, but the cracked beam had to be addressed. And as I said, the lime plastering going into the crack is evidence that the crack has formed before the lime plastering. And we know that in the Puri Jagannath temple, it's almost 100 years back that the plastering started. Yes, that could be the reason to understand when this crack might have happened. And it's possible that these huge stone beams, when they're pushed into position, could crack because of construction stresses. The last one is about the about the... when the land is being chosen, there are multiple things that govern the selection of the site. So even before the construction of the temple, there are a lot of exercises done to see if the land is suitable for the construction of a temple or for anything else that is being constructed. There's an entire chapter in Mayamatham on selection of the site. And that there are certain portions which are very interesting where to know if the soil is of adequate quality, a pit is made of a certain size. It's filled with water. The Sthapati has to take 100 steps away from it and walk back and see what is the level of water. If the water has not gone down at all, you shouldn't touch that site. If the water is completely missing, you shouldn't touch that site. If it's somewhere in between, it's good. So there are very interesting field tests that reflect on the quality of the soil. And interestingly, some of these tests are done today, even in modern geotechnical engineering, of course in a more sophisticated manner, to understand the plasticity of the soil and the composition of the soil. I think we can't, we'll have to take it as it is. It was a different time and context, but I think our focus was on something very different. So we just took it at face value because that was really not what we were focusing on.
I have one question.
Yeah, the last question, please. Yeah. Yeah.
So my name is Hukum and I work with Mr. Rajiv Sethi. I'm an architect by education. So we see this formation on the temple skin across all over India, this positive and negative kind of formation that's in the columns, in the skin of the facade of the temple. What does these mean? Are these a symbolic expression of something, or are they these for structural representation, or there is a science behind these formations? Or because in one of the books by Stella Cambridge, the historian who has written a lot on temples, I read that these are, create this vibrations, positive and negative. When they form, they create some kind of vibrations, and ultimately these vibrations charge the deity which is in the Garbhagriha. So I want to know your brief view. Are there any other reasons?
It's very difficult in the sense, there are people who work on this, try to measure vibrations in temples and so on. But I think at least I don't understand how it works. It's very difficult to link something like that to form. And from whatever little I have worked on and engaged with the Sthapati, I don't think there is an intent to sculpt a form which reflects or deflects or absorbs energy. They really talk only in terms of the outcome, that if you do this, if you follow these principles, the outcome will be good in terms of positive energy. And there must be something, we don't know how this thing is working, but there are people who actually take measurements and work on this. So there was somebody who had talked about how flexible is this Shastra. It's mind-blowing. If you actually look at these ancient texts, it says you have to follow the Shastra. Whatever is written there has to be followed. But in case there's a problem, Then you go with Sampradayam. What is typically done, you can do. You don't have to say, Shastram says this. Even if Sampradayam is not possible, go with Saugaryam, meaning convenience. So you see, it's really magnanimous. And these scriptures are so magnanimous. It doesn't say, this is the rule and follow it. This is the rule. If you can follow it, well and good. If you can't, use common sense. If you still can't, do as little as you can, and it's okay. So that's flexibility.